Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, Episode 2 of 20. What if you could swap out your entire complex reasoning loop for a single 10-line function call? You spend hours writing custom parsers and while loops just to get a language model to trigger a function reliably. The unified agent abstraction is the architecture that takes this off your hands. To understand why this matters, we have to clear up a common confusion regarding older versions of the framework. In version 0.x, developers had to navigate a maze of specific agent classes. You had conversational agents, zero-shot agents, and complex custom chains. If you are upgrading your code, you can forget all of that. The unified agent abstraction replaces all old chains and legacy agents entirely. It provides one clear standardized entry point through a function simply called createAgent. This function exists to manage the React loop. React stands for reason and act. When a user asks a complex question, a language model cannot just execute code. It must reason about the problem, decide to take an action, output text requesting that action, and then wait for an observation before it can reason again. Handling this cycle manually is tedious. You have to parse the text generated by the model, map it to a local function, execute that function, format the output, feed it back into the model, and evaluate if the task is finished. The createAgent function abstracts away this entire orchestration process. Let us walk through a simple implementation using a weather checking tool. First, you define your specific tool, perhaps a function called getWeather that takes a city name. Next, you initialize your chosen language model. Then comes the abstraction. You call the createAgent function and pass it 3 arguments. You pass in your language model, a list containing your getWeather tool, and a system prompt that dictates the rules for the agent. This single call returns an executable agent object. Finally, you invoke this object with a user query, asking for the current weather in London. Here is the key insight into the execution flow. When you invoke the agent, you are starting the React loop. The agent sends the query and the tool descriptions to the model. The model decides it needs real-time data and outputs a standardized tool call. The agent abstraction intercepts this call automatically. It executes your getWeather tool with the argument London, takes the resulting temperature data, and passes it back to the model as a new observation. The model evaluates this data, realizes it has the answer to the user query, and generates a final response. You did not write a single loop, and you did not write an output parser. You only provided the tools, the model, and the instructions. The power of the unified agent abstraction lies in establishing a strict architectural boundary. It completely isolates the mechanics of the reasoning cycle, allowing you to dedicate all your engineering effort to refining the quality of your tools and the clarity of your prompts. That's all for this one. Thanks for listening, and keep building.